So there are EOC release questions that just give you a list of real roots. And then it tells you multiplicity, and then you write the equation, which we'll get to in just a second. When they say write the equation, though, they're not talking about in factored form. They want you to actually write the equation in standard form. So highest exponent in the front, constant in the back. So these would, again, all be factored form. Some things, though, that are helpful from the factored form. Sorry, my camera's so super crooked. Things you can notice, we want to pay attention to the fact from the graphs that these are our zeros. So I have a 0 when x is equal to 1 and when x is equal to -5. Now, in factored form, that's x minus 1 and x plus 5. The way you got there would be that x equals -5. To put it in factored form, in Math 1 and Math 2, you took the factored form to find the 0. So you set it equal to 0 and solve for the -5. Now I'm giving you the -5 more times than not, and you have to be able to find the factor so then you can multiply them together. So we want to get this equal to 0, and so the inverse of that -5 is adding it, so x plus 5. So getting it back to everything on one side equals 0. Now you have your factored form. We have our x equals 1, so again, we got to move him over. So that's going to be x minus 1 as a factor. Now, this negative in the front just turns our graph upside down. Quadratic, super easy to see. And you've done a lot with quadratics in your math career so far. So I've found that most of you guys see the pattern and the changes in quadratics a little easier. And hopefully, I'm in hopes that you can take that and then apply it to all the wiggly squiggly polynomials we do in the future. This is -2. We're going to call it 8. It's not a good one. Good point up here. If we're talking about increase and decrease, so increase is going up from left to right, decrease is going down. This has two directional changes, so I know that this finished equation is going to be to the second power. So increase, decrease, it's going to be the second power. So since it is to the second power, that means I know I have two solutions for sure. The part that's new now, like if you can remember back in Math 1, you had quadratics that were like sitting over in quadrant 2 and they didn't cross the x-axis at all, and we just called it no solution, stop. Like stop doing the math. If you ended up doing quadratic formula or anything like that, you usually got to where you had the square root of a negative number, and you can't, in Math 1, you couldn't take the square root of a negative number because you hadn't done imaginary numbers yet. But what we want to know is that since it's two solutions, this can have a couple of different combinations. They can either be real solutions, which means you can visually see them cross the x-axis, or imaginary solutions. With two options, imaginary has to travel in pairs. So imaginary, like think about your imaginary friend when you were a kid. Imaginary friend did not exist unless you were there. So that's two of you. So we could have two imaginary solutions, or we could have two real. You could have one real, but that wouldn't work because that leaves you with one left over, and imaginary has to travel in pairs. So looking at the second one, so I have decrease, increase, decrease. That's 1, 2, 3. So when we're done with this function, multiplying it out, it should be to the third power, which means there will be possible 3 solutions. And then the combinations of those could be 1 real to 2 imaginary, because then that's you and your imaginary friend, so we're good there. We could not do 2 real because that leaves me with 1 imaginary option, and then my other choice would be 3 real. And those are the only combinations that would work. And I know I've said it 3 times already, but imaginary has to travel in pairs. So no matter what the combinations are, that right-hand side is the way I always write real first and then imaginary second. But imaginary has to be 2, 4, 6, 8. There can never be one imaginary solution because they will say, what are the possible combinations of solutions? And again, you know it's out of 3 because there's 3 directional changes. Decrease, increase, decrease. Now, we see that our factored form is here, but our zeros are at a -2, a +1, so x equals -2. X equals +1, and x equals 3. When those all flip, like get everything back over, that's going to be x plus 2, which we see here. This is going to be x plus 1, which we see here. And this is going to be x minus 3. Oh, I said plus. I didn't mean to say plus. minus 1, or minus 3. So anything that's a positive root, your factor is going to be minus. Then you are going to multiply these together, which we're going to do at the end. I was trying to save time and not do everything all at one time. So then we're going to multiply these out and get a final answer. This minus in the front is why this is going in this direction. So speaking to end behavior statements. The next guy, we have decrease, increase, decrease, increase. So that means I have 4 solutions. So I could have 4 real. I cannot have 1 real because that leaves me with 3 imaginary, and that's an odd number, so that won't work. So I could do 2 real, 2 imaginary. Then I could do 4 imaginary, and that's it. Because I couldn't do 3 real, that leaves me with 1 left over, and imaginary again has to be 2, 4, 6, or 8. And then at that point, you're left with 1 real, 3, and then 0 real would be the 4 imaginary. So that's your combination possibilities. Our 0 is at -1, so that would be that x plus 1 is a factor. A 0 at 2 is going to be at x minus 2. Now, notice this squared. If it is an odd degree, so that would be like to the 1 power, to the 3rd power, to the 5 power, it is going to run through that x-axis. So it crosses all the way through. So no stopping. So 1, 3, 5, and so forth. As far as what you guys normally see, it's either 1, so it's to the 1st power, 2nd power, 3rd power. Every now and again I've seen a 4th power, but that's as high as they get, usually from the ones I've seen so far. But again, 1 time means it crosses through, and that means it has a multiplicity of 1. Multiplicity of 1 crosses through, and that's to the 1 power. That 2 power, it's an even degree. An even degree is a bounce. So it hits the line, hits your x-axis, and then it returns back in the direction it was coming from. So it never crosses the x-axis. It just bounces off of it. And that would be for 2, 4, 6, 8, all evens all the way through. The one you really see for most of your bounces are going to be 2s and 4s. In 4, the bounce is so, it's just like an elongated bounce. It gets wider. So it sort of just hangs out on the x-axis for a minute and then kicks off. Then again we have, so that's going to be our 2, and then we have a 0 at a positive 4, which is at x minus 4. It did just go running straight through that x-axis. That's why it's a multiplicity of 1, or the 1 power, and I didn't write that out here. So multiplicity, they'll write it like this with the 2 as well, multiplicity of 2. That one would probably be the one most of us mess up. So that 2 would be written as 2 to the multiplicity of 2. This portion is not a new solution or a new root. That is telling you that this one happened twice. So if we're looking at our next graph, we have x equals -2. That is a bounce. It went whoop, poof, and it never crossed the x-axis. So we know that's a multiplicity of 2, and in factored form that looks like to the 2nd power. So that would be, if it was a list of our solutions, it would be 2 to the multiplicity of 2, which means you would use it twice. And that would be x plus 2, x plus 2, just like x plus 2 squared means. Again, you've got your 3. It also hit the x-axis and then turned around, did not cross through. So that would be 3 multiplicity of 2 again, which you can see that to the 2nd power here. And that's going to be x minus 3, x minus 3, or x minus 3 squared. But when we're multiplying them together, the x minus 3 to the 2nd power is not as useful because you guys distribute that exponent for whatever reason, and that's not what happens. If there's addition or subtraction inside the parentheses, that squared means write it twice. So I would practice writing it like this, not as they did up in the factored form here. Another just brief call out, because I think we hit on it really quickly last week, this week. This is all positive on our graph, and then everything below that line is negative. So not speaking to increase or decrease, but positive versus negative, because you will see some questions along the way that say, like, when are they increasing and positive? So if we're looking at this graph, the only place that is increasing and positive would be right here to the term. So you would give that mini domain from x, so from 1 to 2 is the graph positive and increasing. And we'll do more with that as well along the way, because I know it's not something we grasp super fast typically when I've had conversations with students. All right, so I'm going to boogie past all of that and get to the point of the real writing. So we're doing real roots right now, so that means only the ones that are actually touching the x-axis. So you can actually check your work. You could go to Desmos and you can type in your answer and you can see where it crosses. Or if it's multiple choice, you could type in all of the choice answers, A, B, C, D, and see if it crosses in those places. So real roots, remember, roots is the same thing as zeros, it's the same thing as x-intercepts, and it's the same thing as solutions. And the word solutions doesn't play as much role anymore, but back in Math 1 and Math 2, when you were doing solutions to quadratics and things of that nature, it's the same thing. So this one, in this case, there's 2 of them, which means it's going to touch the x-axis twice, which we know is going to be a quadratic equation, so it should be x squared when we're done. Now, you will find a pattern and not have to do this much math every time, but because we have complex and imaginary solutions coming up in the future, I do suggest practicing it this way for a little while before you just get to the memorization part and start just like pumping out factors, because it applies when they're imaginary and complex and all that good fun stuff. It makes it a lot easier. So since these are 1 and -4, so x equals 1, x equals -4. Those are my roots, zeros, intercepts, and solutions. I need them to turn into factors. So I'm going to move that 1 over here with the x. So that means I would do inverse operations because we want to get the thing set equal to 0. So now I have a factor. And you're going to do the same thing for that -4, but we're going to add 4. Add 4. And so these guys go away. Mark that out. And then x plus 4. Now, the factored form of this equation is x minus 1, x plus 4. Awesome. Not typically the way they ask for your answers to be given, especially on the EOC. It's a good place to, like, if you wanted to go compare or check your math, but I will not, on any quiz, test, worksheet, want the factored form. I want the actual standard form. So you can either FOIL, you can box method, or you can distribute, however you want to do it. Now, if you do FOIL, I would do, so x times x is x squared. I've watched students get wild and crazy and draw all of their arrows at one time. Don't do that because it doesn't help you. X times 4, so that's our outer. It's going to be 4x. And then we have -1 times x. This is our inner, if you're a FOIL person. So -x, and I guess I should put that +4 because that's a plus. And then last but not least, -1 and 4. So that's our last, and that's going to give you a -4. Then you're going to clean up like terms. So I have x squared. If I have $4 and I lose $1, then I have 3. And now you have written the least common multiple, the easiest one without any more information of just those 2 roots. Like, it didn't say it passed to another point. It didn't say that, it had any sort of change in steepness, just standard, those roots. This would be a possible equation that had those roots. And you could go to Desmos and type in this form, and they should graph right on top of each other to make sure you multiplied and then combined like terms correctly. Now, I'd kind of jumped off a cliff because you have all of today's work as well to do this. But again, so 2, multiplicity of 3. So that means I have x equals 2 3 times. So 3 times, that means I'm going to write this factor and do a lot of multiplication this time. So this is going to become x minus 2, and that's 1 of them. X minus 2, that's 2 of them. X minus 2, that's 3 of them. Now 0, x equals 0. To move that 0 over, it doesn't do anything. That means I just have an x. Don't lose that guy. So this one, I wrote all the ones that I've watched you guys make mistakes. So 0 is a factor. It's just x. Now, 3 over 4, good times. This is the other reason that x equals is very helpful. I memorized a pattern as well, but if I had to get this set equal to 0, I need the 4 out of the basement. So I'm going to multiply both sides by 4 first. And now I have 4x equals 3. It is still not equal to 0 yet. Now I'm going to move that over just like I did on my other ones, and I'm going to end up with 4x minus 3. Now, I like to think that the guy on the bottom jumps to the front, so for every fraction. So if I was doing, let's see, if it had a root of 1/2, that factor is going to be 2x minus 1. So the guy on the bottom jumps to the front, and then it's opposite of whatever it is. So let's say negative 3 over 4. So negative 3 over 4, 4 jumps to the front, and it becomes opposite. So 4x plus 3. Every one of us have tried and will continue to try, unless you hear me out right now. There are no decimals and there are no fractions in factors. They become a mix where there's a number in the front. So let's see if I can think of another one. Let's do 2/3. So it's going to be guy on the bottom, hops to the front, opposite of whatever's in the back. So that's going to be 3x minus 2. One more for good measure. Let's do a negative 1/4. Guy in the bottom jumps to the front, opposite of whatever it is before. So it's going to be 4x plus 1. And I lied, I'm going to do one more. Let's do an ugly one. 5 over 7, and we'll leave it positive. So guy in the bottom jumps to the front, becomes opposite. So 7x minus 5. So hopefully with that little drill of 5, please, 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 you cannot put x minus 3/4. That is not an option. You have to switch it. Now from here, we're going to take up a lot of space. I have to do this all the time. The factored form of this equation, like if you wanted to put it in Desmos, that would be a 3. So you could compare it, knowing that you at least got the factors right, and just to make sure you catch if you made any like small computation errors in your multiplication, that would be what I would put in my first line. And then the second line would be my solution. I would save this guy for last, that x, because all that's going to do is change all of the exponent powers and make them go up 1 and maybe tack on an x at the end. So I would do him very last. X minus 2, we're going to do it 3 times. So we're going to do it 1 time. X minus 2, and I'm switching to box method this time. So x times x gives me x squared. Negative 2 times x, so you're working in like this, negative 2x. We're going to do it again. Negative 2 times x down here is negative 2x. Negative 2 times negative 2 gives me a positive 4. The box method is nice after this point because you're now no longer doing binomial times binomial. Now I would check off 1, 2, because those are the 2 I just took care of. I want to clean up. These are like terms. So I'm going to have x squared minus 4x plus 4. Before I can move on, I still have that x minus 2. So we're going to do it again. This time it's a 3 by 2. And again, you can do it by distribution. As a mass, most of you do not get really good at maintaining and keeping up with every number as they get further along than binomial times binomial. So I highly recommend learning box method if you don't know it, just for this at least. X times x squared is going to be x cubed. Negative 4x times x, and I'm just going across the top. I'm going to distribute that x all the way through. So it's negative 4x squared. X times 4 is going to give me 4x. Now I'm going to multiply everything through by that negative 2. So this is kind of like distribution, except it's just keeping it, you know when you miss one because you have an empty box. So x squared times a negative 2 is negative 2x squared. Negative 4x times a negative 2 is going to give me 8x. 4 times a negative 2 is going to give me a negative 8. Now we can go check that guy off. So that's the third one. We're done with it. We're going to clean up in our box any like terms. So these guys are like terms. These guys are like terms. So I end up with x cubed minus 6x squared plus 12x minus 8. And I was slowing down just to make sure that I didn't make a big mess. And I just realized I went on the screen. Sorry. So x cubed negative 6x squared 12x minus 8. Whew, we did a lot of math already. We're still not done. So this is the downside to this, is it takes some commitment to get to these guys. All right, I'm going to leave that last x for very last. So I have 4x minus 3 is my other factor in my list when we made them. So we're going to distribute the 4x through all the way across the top. So that's going to be 4x. There's 3 and 1, so that's going to the fourth. Negative 6 times 4 is going to be a negative 24. I have x squared times x, which is going to give me x to the third power. So I just added an x. 12 times 4 is going to give me 48. X times x gives me x squared. Negative 8 times 4 is going to give me a negative 32. There's not an x up there, but there is an x out here, so I have an x. 4, 3, 2, 1. And that works because we have 3, 2, 1, none. If somebody was missing, it would not look so nice and neat and sequential. So now we're going to do the bottom. So negative 3 times x cubed is negative 3x cubed. Negative 3 times a negative 6 is going to be a positive 18. X squared, because there's not an x down here. 12 times a negative 3 is going to be a negative 36. There's one x at the top, so bring it down. And negative 3 times a negative 8 is going to be a positive 24. Now, we're still not done. Clean up. So these guys are like terms. These guys are like terms. These guys are like terms. And usually it'll always be on the diagonal, again, if everybody shows up. So now I'm looking at 4x to the fourth power. I have a negative 4, 5, 6, 7, negative 27, x to the third. 18 and 48. It's going to be 50, 66, I believe. I want to make sure I check. 18 and 48. Yep, it's 66x squared. Negative 36 and negative 32 is going to give me a negative 68x squared plus 20, oh, not squared, sorry, plus 24, just negative 68x. So we are adding these together to pull them out. So just like we added when we did FOIL, those guys together to combine like terms, when you're coming out of box method, you're just adding. To go in, you're multiplying. Now we're almost done. Almost done. So we checked off the 3x minus 2's. We checked off the 4x minus 3. Now we need to check off the x. So ultimately, we're multiplying this whole thing by x. So the final answer is going to be over here. X times 4x to the fourth is going to be 4x to the fifth. X times a negative 27. X cubed is going to be a negative 27. X to the fourth. X times 66x squared is going to be 66x to the third. So we're just adding one more x. That negative 68x is going to become x squared. And then that 24 that was a constant is now going to grab an x. And now you've written that polynomial. Unfortunately, these just take time and they take space. If you cheat yourself, count on missing one of the EOC questions because it is in the EOC release packet. And multiplicity does add more work, but I can't say enough that a lot of us look at this and think the 2 and the 3 are a 0. It's not. Look for your parentheses. So this is 1, this is 1, this is 1. This simply means that 2 happens 3 times. So we could write it like this as well. It means the exact same thing. But do not give me an answer in factor form. I need to see that you can multiply all the way through. No offense or be offended. You also need to practice the multiplication all the way through and holding on to your math all the way through. Again, if you wanted to go check that last one, you could plug this in your first line of Desmos and this in your second line of Desmos, and they should graph. Whoops, I'm still not even on the paper. Sorry. They should graph in Desmos on top of each other. And so that would be a way to make sure you aren't getting them wrong. Hang in there, guys. Polynomials are huge.